Assalamu alaikum students. Hope you are fine and happy. The process of midterm examination has been completed successfully. Now we will start the lectures, remaining lectures of this semester. Today is our first lecture of this week. I have shared here the chapter number 6 of Dr. Khalid Parvez, of the book of Dr. Khalid Parvez, which is the principal component analysis. In many explanatory studies, the number of variables under considerations are too large to handle. A way of reducing the number of variables to be treated is the discarded the linear combination which have smaller variance and study only those which have larger variance. For example, if we are interested in the analysis of physiological characteristics of individual, we may make the measurements of the facial length and breadth of the ears, etc. Basically, it is a technique of variable reducing in a form of linear combinations. The linear combinations, those linear combinations which have maximum correlations, which are correlated with each other. We may be interested in only those linear combinations which shows considerable variations. The other linear combinations vary so little from one person to the next that study of them will tell little of the individual variation. In other words, to examine the relationship among a set of p-correlated variables, it may be useful to transform the original set of variables to a new set of variables which are uncorrelated with each other and called principal components. Principal components is a technique of finding those uncorrelated variables. It is a variable directed techniques which is appropriate when the variables arise on an equal footing, so that the example, we do not have a dependent variable and several independent variables as in multiple regression analysis. Here I also have shared an examples in which we have made principal components which have two variables x1 and x2. The variance covariance matrix of x1 and x2 is given here. From the variance covariance matrix we obtained the principal components. Also find the covariance matrix of the principal components and prove that B transpose B is equal to identity matrix. To find the principal components, first we will find the eigenvalues and eigenvectors of variance covariance matrix. To find the eigenvalues, let sigma minus lambda I determinant is equal to 0. After replacing the values of sigma, that is variance covariance matrix, and identity matrix of order 2 and lambda, we obtain after solving these equations, which is a quadratic equations, we have two values of lambda. Lambda 1 is equal to 193.311 and lambda 2 is equal to 54.6688. To find the principal components, now we find the eigenvectors corresponding to the eigenvalues. Now, to find the eigenvectors, we have to solve the equation variance covariance matrix into beta k is equal to lambda k into beta k. First we take k is equal to 1, so variance covariance matrix into beta 1 is equal to lambda 1 into beta 1. After replacing the respective values, we obtain equation number 1, beta 21 is equal to 0.317 beta 11. For unique solution, we know that beta 1 transpose into beta 1 is equal to 1. So we have beta 11 into beta 21 into beta 11 into beta 21, taking transpose of this metric is equal to 1. After solving, we have beta 11 square into beta 21 square is equal to 1. Replacing the respective values of beta 21. Beta 11 is equal to 0.317 beta 11 whole square. Solving this equation, we have beta 11 is equal to 0.95853, and similarly beta 2 is equal to 0.32. Now we have eigenvalues corresponding to eigenvalue. We have eigenvectors corresponding to the eigenvalue. Lambda 1 is equal to 193.311. We have beta 1 is equal to 0.953 and 0.302. Similarly, we find the eigenvector corresponding to lambda 2 is equal to 54.668. After solving the equation and replacing the respective values, we have beta 2. The second eigenvector is equal to beta 2 is equal to 0.306 and minus 0.951. Now the first principal components is we obtained here. Y1 is equal to beta 1 transpose into x. Beta 1 is equal to 0.953 x1 plus 0.302 x2. It is the first principal component. Similarly, the second principal component is here, given here. Y2 is equal to 0.306 x2 minus 0.951 x2. Sorry, y2 is equal to 0.306 x1 minus 0.951 x2. The covariance matrix of the principal component is equal to lambda 1, 0, 0, lambda 2. Lambda 1 and lambda 2 is the eigenvalues, which is 193.11 and 0, 0 and 54.668. Finally, beta is equal to beta 1 into beta 2. Now, beta 1 is equal to beta 11, beta 12, and beta 2 is equal to beta 21, beta 22. Replacing the respective values, we have this. That one, please wait. Now, beta transpose into beta is equal to 0.953, 0.302, 0.306 and minus 0.395. Multiply the transpose of this metric, we have identity metric 1001. So beta transpose into beta is equal to I.